Chapter 4, Lesson 7, Inverse Trig Functions. Go ahead and pause here and write down these definitions. All right, so it says to use the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent when we are finding the lengths of sides of a right triangle. So notice that we're using the actual trig functions, not their inverses. So when we use the calculator, we're using the actual sine, cosines normally, not the inverses. When do we want to use the inverses? So we'll use the inverse functions, all of them that are listed above, to find the measures of angles of a right triangle. So when you do that one, you're going to push the second key first and then the trig function that you want to get that inverse to pop up. A couple notes here. Notice that the inverses can be written as either whichever trig function you want to the -1 power and then the x. So you could have cosine to the -1x or sine to the -1x. Or you'll notice in this book, they also use arc trig function. So they might have arc sine x or arc cosine x. Another note, if you take the inverse sine times the actual sine, they will cancel each other out. And when we get down to the bottom, when we have to do exact measures, you're going to need your unit circle out today. So if you need to pause and get that out, go ahead and do that. The first one wants us to use our calculator to find the measure of each. So I'm going to go to the calculator. Right now I am in radians according to the top, and I want radians first. So I'm going to do the inverse tangent of 2.37. In radians is 1.17. And then I can just change the mode to degrees and do it again. And it is 67.12 degrees. Same thing for the inverse cosine. Right now I'm currently in degrees. So I'll put 148.54 degrees. Change the mode to radians. The same thing would give me 2.59 radians. On these ones, they want us to not use our calculator. They need us to use the unit circle. And I have mine here, so it's going to be hard for you to not be able to see this, but remember that when we did our unit circle, we have it written as x, comma y, and x is cosine, sine, and at the back then we wrote tangent. So the first one wants me to give the cosine of -3 over square root of 3 over 2. So if I'm looking at my unit circle, I see it at 5 pi over 6 radians and 150 degrees. Now, there is a second negative square root of 3 over 2 at 210 and 7 pi over 6. However, they gave me that the domain they wanted me to work with was only from 0 to pi. So I don't list that one. The second one wants me to do the inverse sine of -1/2. So remember, sine is the second number. So I'm looking, where is the sine? -1/2. But I'm only looking from negative pi over 2 to positive pi over 2. So I'm looking on the right half of the unit circle, and I see it there at 11 pi over 6, or 330 degrees. Because remember, negative pi over 2 is 270, and positive pi over 2 is 90. So I'm looking in between negative 270 to 90. That's why I'm only using the 11 pi over 6. Last one is, where's the tangent? The square root of 3, positive, on, again, this right side of the unit circle. And I think I only see it at pi over 3, or 60 degrees. On this one, we're doing composite functions, and we did composites in Algebra 2 when we talked about fog and goth. And so when you're doing these types of problems, you start with the inside of the function and then work your way out. So first I'm looking for where is the tangent 1? And it is at pi over 2 or 90 degrees. And then the second thing I want to do then is ask myself, okay, what is the sine at that pi over 2 or the sine at 90 degrees? And the answer is 1. The next one says to do the cosine of 7 pi over 4, which is down in quadrant 4. The cosine of 7 pi over 4 is square root of 2 over 2. And then what is the inverse cosine then of square root of 2 over 2, or what is the degree or radian measure? Either one is fine. And I see that at pi over 4 or 45 degrees. Number 3, I'm doing the inverse tangent of -1, which is at 3 pi over 2 or 270. And then I need to do what is the sine of that 3 pi over 2, and it is -1. The last one wants me to do the tangent of pi over 4. The tangent of pi over 4 is 1. And then we see that arc cosine, and that just means the inverse cosine. And where's the cosine 1? It is at 2 pi or 360 degrees. On this triangle below, it wants me to solve for these missing sides and missing angles. So first I'm looking for measure of angle A. So I'm going to put the theta there. I have hypotenuse information. I look at the theta compared to the 5, and that is opposite the triangle from it. And so I know I'm going to use sine. So the sine of theta I know is 5 over 13. Now, how do we solve then for theta? How do we cancel out the sine? According to our notes, it says we can take the inverse sine. Whatever I do to one side, I must do to the other. The sine and inverse sine over here will cancel out, and it'll just give me theta. And I'm working in degrees here. I'm doing the inverse sine of 5 over 13. And that gives me theta to be 22.62 degrees. Now if I changed, I'm looking for angle B. If I move the theta here, now I'm doing cosine because the 5 is right next to the theta. So I'm going to do cosine of theta is 5 over 13. How do I get the cosine to go away on the left? I do the inverse. Whatever I do to one, I do to the other. 67.38 degrees. For the last one, I'm looking for the missing side, and I could just use our regular Pythagorean theorem. A squared plus b squared equals c squared. 13 squared minus 5 squared is 144, and the square root of 144 is 12.